Okay, today we are going to look at Chebyshev and the measures of dispersion. And with Chebyshev is a Russian mathematician who brought up a formula, or let's say a theory called Chebyshev theory or theorem. And this theorem talks about sharing or spreading a distribution. Do you get it? So in case when you want to even find the minimum percentage of a particular distribution, you use Chebyshev theorem. And this one we are talking about normal distribution. We are talking about normal distribution. And for Chebyshev theorem, one thing about Chebyshev theorem is that one it can be used for every distribution. Just have this in mind that Chebyshev theorem can use every distribution, but this one the emphasis will be more on the normal distribution. Okay, so with Chebyshev theorem, he said we have K, and this K is standard deviation. K is standard deviation, or you can call it Chebyshev standard deviation. Do you get it? So for his formula, he said before you can find for the minimum percentage of a distribution, the formula is 1 minus 1 over K squared. So this is the formula for finding for the minimum percentage of a distribution. Do you get it? So in every distribution, assuming the number of students in a class, they are being paid an allowance, and you want to find for the minimum percentage of that particular allowances of those students, you use Chebyshev theorem, and the formula is 1 minus 1 over K squared. So this is what we are going to do. So assuming you have K to be 2, that is 2 standard deviation, right? And so if you are to find for the minimum percentage, it becomes 1 minus 1 over 2 squared. You have 1 minus 1 over 4, right? And so this one will give you 1 minus 1 over 4. You have 0.75. Because we want to find for the percentage, we multiply it by 100. So times 100. Now we have 75%. So Chebyshev said 2 standard deviation is 75%. That is what he proposed, and you can clearly see it is true. So 75% is found within 2 standard deviation. And the same thing, if you have been given 3 standard deviation, it becomes 1 minus 1 over 3 squared. And so this one too will give you 1 minus 1 over 3 squared will give you 0.88889, right? Then you multiply it by 100 to get that is 88.89%. So this is 3 standard deviation. So if you want to find the percentage or the minimum percentage within 3 standard deviation, it is 88.89%. So in every question, if they give you the number of standard deviation to be 3, you just use this formula, 1 minus 1 over K squared. You get it? Then you calculate for the percentage. Okay, now we know how to calculate for the minimum percentage when K is given. Now let's look at how to calculate for K when the minimum percentage is given. Okay, so assuming they've asked you what is the number of standard deviation, or what number of standard deviation is 70% or 75%. So let's use 75%. Okay, so what number of standard deviation is 75%? Now you know the formula already, right? So 1 minus 1 over K squared, and this formula is used to calculate for that is the minimum percentage. It is used to calculate for the minimum percentage, right? Okay, now we have been given the minimum percentage to be 75. So 1 minus 1 over K squared equal to 75%, right? Okay, it will be more simpler or easier when you change this to decimals. So you know 75% is it's 0.75, right? So here you are done with your calculation. All that you need to do is what? You change what? The subject, because you want to calculate for what? K. Okay, so here we have 0.75 here, 1 minus 1 over k squared. So we are going to multiply through all the terms. We have three terms. Term 1, this another term, this another term. So we are going to multiply this k squared by this one. When we finish, we multiply the k squared by this term as well. When we finish, we multiply it by this term as well. Okay, so we say k squared times 1. This is the first one. Then you say minus. Now you come to the second part, which is 1 over k squared times k squared, right, equal to, now the last part, 0.75 k squared. You see that? So we have multiplied through by what? K squared. Now this k squared will multiply this k squared. So it is now in linear, in line form. Okay, so k squared times 1 is what? K squared minus, you see this one has cancelled this, leaving what? 1. Now you have 1 equal to 0.75 k squared. Do you see that? So now we want to make k what? The subject. So we group like terms, right? So you have k squared minus 0.75 k squared equal to, this one will cross the equal sign to become 1. So now, do you know we have coefficient of 1 here? So this 1 minus 0.75 will give you what? 0.25. So you have 0.25 k squared. Do you see that? Equal to 1. So now what you need to do is what? You divide both sides by 0.25, since you are calculating for k. So you have 0.25, 0.25. Now this one cancel out this. You have k squared equals 1 over 0.25. Okay, we are calculating for k, not k squared. Do you get it? So we need to bring a square root here, another square root here, in order to cancel this squared here. Now this k squared is equal to, this one will give you 4, and so you square root this side, same as this side. You see that this square will eliminate the square roots. So now k is equal to, square root of 4 is what? 2. So you can say 2. So now k is equal to 2. Chebyshev said 2 standard deviation is equal to what? 75%, and it is true. Or if the 75% is given and you are being asked to calculate for the number of standard deviation, this is the procedure to go through. Do you get it? You first write the formula. You know where the minimum percentage is supposed to be here, right? You change it to decimal, then you make what? Change of subjects. That is it. So you make k the subject by either multiplying through, or you can bring this one here and you do cross multiplication. Anyhow that you want to do, you still arrive at what? 2. K equals what? 2. So we know the number of standard deviation is what? 2. Okay, so that is it. Let's also try another question, then we move on. Assuming you have been given a percentage, let's say 92%, and you are being asked to calculate for what? The number of standard deviation. Same thing. What do? You know 1 minus 1 over k squared will lead to what? The minimum percentage. The minimum percentage Chebyshev is talking about. So here 1 minus 1 over k squared is equal to 92%. That is the minimum percentage given in the question. Okay, what again? Here we change this one to decimals, as we already said. That is k squared equals what? 0.92. I hope you see that. So here we are going to multiply through by k. Now we multiply through by k. You have k squared times 1. You have your minus here, 1 over k squared, which is here. Then you multiply it by k squared again, equal to 0.92 times k squared. You see that? Okay, so this k squared will cancel out this k squared. Now what do you have? K squared times 1 will give you k squared. This will give you minus 1 is equal to this 0.92 k squared, 0.92 k squared, right? So here you make k k the subject, you group like terms first. That is k squared minus 0.92 k squared equal to this one, of course, the equal sign, so 1. Now we have coefficient of 1 here, so 1 minus 0.92 will give you what? 0.08 k squared equal to what? 1. Now you divide both sides by 0.08, so you move on. You have k squared equals 1 over 0.08 will give you 25 over 2, or let's say, okay, so 25 over 2. So now you bring your square root here to eliminate the square, your square root here to eliminate, okay, to eliminate the squared here. So this one, you have k equals, now square root of 25 on 2 will give us 3.54. So we can approximate it and say k equals, the approximate value of k is what? 3.5, right? It's 3.5. So if you want to confirm the percentage, you can further on go on and say 1 minus 1 over 3, because from the formula we have k and now we are saying k is 3.5. So you can confirm by saying 3.5 squared. Do you get it? The percentage that you are supposed to get should be closer to this or a little more than this, because we rounded the number. Do you get it? Okay, so 1 minus 1 over 3.5 squared. We are getting 0.91837. Okay, so this one, since we want to calculate for the percentage, we multiply it by 100. If you multiply it by 100, what do you get here, right? So you have 91.8%, and 91.8%, we want a whole number. Do you get it? So you round this one to this one, you get 92%. That is what was given in the question. Do you get it? So always after getting the key, you can further on confirm the answer, because sometimes you just round the number off. The percentage will be a little lesser. Do you get it? Yes. And even if you get that, still you can say your answer for k is what? Correct. Okay, so that is it. Now we know how to change k to the minimum percentage, or the Chebyshev standard deviation. That is the k to the minimum percentage, and we know how to change the minimum percentage to what? K. Now in our next lesson that we are going to look at, we are going to talk about something we call range. So Chebyshev also said we have a way of calculating for range of particular set of what? Numbers. So we say range is equal to what? The mean plus or minus Chebyshev standard deviation multiplying what? The normal standard deviation. Do you get it? And from measures of variation, you realize range is equal to what? The highest value minus what? The lowest what? Value, right? So it means for the range we have the highest and what? The lowest value. I hope you get that. Okay, and this mu that you see over here is what? Mean. It represents mean. And this k that you see is what? Chebyshev standard deviation. And put it in mind, with Chebyshev standard deviation, this one has no units. So in the question, any number that you see that will be related to standard deviation without a unit is what? K. Do you get it? And so with this standard, the normal standard deviation, sometimes it can be given $20, but with this k, sometimes 3, straightforward like this. Okay, so now let's look at how to even calculate the range. This addition sign here represents what? The highest value, and this subtraction sign represents what? The lowest value. So it means if you bring the highest value here, if you bring it here, it means you are going to use the plus. It becomes the mean plus Chebyshev standard deviation multiplying the normal standard deviation. Do you get it? If you bring the lowest value here, it means it is the mean minus Chebyshev standard deviation multiplying the normal standard deviation. So that is the difference. But immediately you combine them, you get range. So you also have to combine this to get what? This. Okay. Now let's solve one question and look at how the range also works. Now we are going to solve an example under Chebyshev theorem, and it says the mean price of houses in a certain neighborhood is 60,000 Ghana cedis. So we have the mean or the mu to be what? 60,000 Ghana cedis, and the standard deviation is 10,000 Ghana cedis. Now they are saying the standard deviation is 10,000 Ghana cedis, and mind you, I said with Chebyshev standard deviation, which is k, has no unit, right? So if you are having 10,000 Ghana cedis, it means it is the normal standard deviation, this, not k. So 10,000 Ghana cedis. Okay. Find the price range for which at least 75% of the houses will sell. So 75%, that is the minimum percentage given. Okay, so we are to calculate the price range. So this is the question. Now let's look at how to solve this simple question. Okay, so you know the range. When we talk about range is just a gap, right, or an interval. So it could be 2 to 10. There's a range, and so there's what? The lowest value, and there's what? The highest value. That is it. Okay, so here we are going to find for the lowest value, and we also find for what? The highest value. After that, we put it in this way. That will be what? Our range. Do you get it? So now we know the formula for range. Let's put down our formula. The formula is range equals your mean plus or minus Chebyshev standard deviation k multiplying the normal standard deviation. Okay, so we are to calculate for the range. Now mean is already given, Chebyshev standard deviation k was not given, and we have the normal standard deviation, but we know how to change the minimum percentage to what? Chebyshev standard deviation. So we can do that. Now I said range is what? Let's say 2 to 10, a gap or an interval, right? So there is the lowest and there is the highest. So it means we have to calculate for the lowest value, and that is mean minus, because I told you the minus take what? The lowest value, multiplying Chebyshev standard deviation times the normal standard deviation. So that's the lowest value, and for the highest value you have mean plus Chebyshev standard deviation multiplying the normal standard deviation. So this is the lowest value, the highest value. So this is what we are going to do. But before you calculate for the lowest and the highest value, you need what? K, right? And you can calculate K from this percentage. Okay, we know if you want to calculate for K, we say 1 minus 1 over K squared. This formula is used to calculate for what? The minimum percentage. So it is equal to the minimum percentage. Do you get it? So now the minimum percentage is given. We have 1 minus 1 over K squared equal to, the minimum percentage is what? 75%. And it would be more simpler or easier when you change this one to what? Decimals. So 1 minus 1 over K squared equal to 0.75. Now what you do is you multiply it through by K squared. You already know how to calculate for K. So fast forward. K will multiply this. So K squared times 1 minus 1 over K squared times another K squared, right? Then equal to, we multiply this one too by K squared. K squared. And so this K squared will cancel out this. Do you see that? So now we have K squared times 1. So K squared times 1 will give us K squared. Minus, this one has cancelled out this, so leaving only 1, minus 1 equal to 0.75 K squared. Right? Now you have k squared here, you have k squared here. So what you do is you group like terms. So k squared minus, when this one crosses the equal sign, it becomes negative k squared, right? Equal to, when this one crosses, positive. Now don't forget, we have 1 here. Coefficient of k squared is what? 1. But because it is 1, we don't normally write the 1. So 1 minus 0.75 will give you what? 0.25 k squared, right? Equal to 1. Now we are looking for k, not 0.25 k squared. So what we do is we divide both sides by the coefficient of what? K squared, which is 0.25. 0.25. So our k squared now is equal to 4. Mind you, we are looking for what? K, not k squared, right? So here, what do we do? If you want to eliminate this squared, you just have to bring a square root at both sides. So square root here, another square root here, so that this square root will cancel out this square, right? Leaving the k here, equal to, now what is the square root of 4? It is 2. So 2, 75%, the minimum percentage, which is 75%, is what? 2 standard deviation according to what? Chebyshev, and you know it. So now we have our k. We have our k. So we can say k is equal to what? 2. So now we can calculate the lowest value and what? The highest value. Okay. So let me clean the calculation for k so that we use the space for the lowest value and the highest value. So for the first one, the lowest value, we are saying it is equal to the mean, and mean is what? 60,000. So you have 60,000 minus Chebyshev standard deviation is what? 2. Multiplying the normal standard deviation given in the question, which is 10,000. Okay, so your lowest value is equals 60,000 minus 20,000. Now lowest value equals 60,000 minus 20,000 is what? 40,000. So the lowest value is what? 40,000. Now you calculate for what? The highest value, that is HV, equals, your mean is 60,000, so you write 60,000, but here will be plus because you are taking the highest value. Chebyshev standard deviation is 2, so you bring your k, that is 2, multiplying the normal standard deviation, which is 10,000. So you say highest value equals 60,000 plus 20,000. Your highest value equals 80,000. So now you have been able to calculate for what? The lowest value and what? The highest value. Don't forget, I said when you are calculating for range, you need what? The lowest value and what? The highest value. So this is how we are going to put it. So we say the price range because the lowest value is what? 40,000. So 40,000 2, it's not minus 2, 80,000. So this is the price range. You get it? So it means the minimum price that a house can sell, or the minimum price a manager or someone can sell that particular houses, according to this information, is what? 40,000, nothing less than this. You get it? Then the maximum or the highest value is what? 80,000. It means nothing more than this one. Okay, so that is it. Let's also look at the second example under Chebyshev. Okay, so let me clean this one. Okay, so a survey of local companies found that the mean amount of travel allowance for executives was $0.25. So the mean amount is what? $0.25. Okay, per mile. The standard deviation was 0.02. Now here they are saying the standard deviation is $0.02, and you know with the Chebyshev standard deviation, which is k, has no unit. So in this case, it is the normal standard deviation, which is 0.02, because the normal standard deviation has unit, but k has no unit. So have that one in mind. Okay, using Chebyshev theorem, find the minimum percentage of the data values that will fall between 0.20. So that will fall between $0.20 and $0.30. So this is the range given. Do you get it? So we say range. This is the range given. Okay. Now they are asking us to calculate for what? The minimum percentage. And from our previous lesson, we know before you calculate for the minimum percentage, you need to get what? K. So that you apply the formula, Chebyshev formula, 1 minus 1 over k squared, right? So you need k in order to obtain the minimum what? Percentage. Now per the question, we don't have k. We don't have k. So it means you have to calculate for k, and then you use the value of k to find for the minimum percentage. So as usual, we know the formula to be range equals your mean plus or minus Chebyshev standard deviation multiplying the normal standard deviation. Okay, now the range is given, that is minimum value or maximum value. The mean too is given, and we have the normal standard deviation. So it means we can just fix in all the parameters in order to calculate for what? Chebyshev standard deviation, which is what? K, right? Okay, so now there's the minimum value. So we can choose 0.20, or we can also use 0.30. We are still going to arrive at one value for k, right? So here let's start with 0.20. So the lowest value equals your mean minus Chebyshev standard deviation multiplying the normal standard deviation. Okay, so the lowest value here is what? 0.20. So you have 0.20 equals, the mean is what? 0.25 minus, you don't know k, right? So k multiplying the normal standard deviation is 0.02. So that is it. Now you perform your calculations and make k the subject. Okay, so you can further on say 0.20 equals 0.25 minus 0.02 k. So now what do? You group like terms. This is what? K. And so you bring this one to this side, or you can bring this one to this side and bring the k to your left hand side. Anyway, you still get the same answer. So this is negative, so let's bring this one to our left hand side, right? So we have 0.02k equal to 0.25, then this one will cross, so minus 0.20. We have 0.02k equals, now this one will give you 0.05, right? Okay, so we then divide both sides by 0.02, then 0.02. So this one will cancel out this. You have k equals 0.05 over 0.02. 0.02. You have 2.5. So k is equal to what? 2.5. And you know, before you calculate for the minimum percentage, you need to get the value of k before you apply the Chebyshev what? Formula. So this formula is used to obtain what? The minimum percentage. And so we were asked to calculate for the minimum percentage. And before you do that, you need what? K. K was not given in the question, but you had what? The minimum value and the maximum value. So you can use any of them to get what? K, right? So here we know k to be 2.5. So we say 1 minus 1 over 2.5 squared. So this one will give us 1 minus 1 over 2.5 squared will give us 0.84. So we have 0.84. Because we are calculating for what? A percentage, what do? we multiply it by what? 100. You get it? And so 100 is just like 1 2. So now the point is here. So you have 84%. 84%, right? So that is the minimum percentage from the distribution or the question. So that is it. Now we move on to the next topic, that is empirical rule. Okay, now let's look at empirical rule. You know, with Chebyshev theorem, that one can be applied in every distribution, and with empirical rule it can only be applied when you are dealing with what? A normal distribution, that is a symmetrical what? Distribution. And from skewness, we said a normal distribution has what? The mean, all the three measures of location and central tendencies in the middle, right? So you have your mode here, you have the median here, and you also have what? The mean here, right? But here, empirical rule, the emphasis will be more on the mean, right? So anytime you hear mean, just have it in mind that the mean is going to be in the middle, because we are dealing with what? Symmetrical distribution or a normal distribution. So have this in mind. Okay, and we know with the normal distribution, if you move here one, the interval or the percentage here must be equal to what you have here. I hope you get that. So if you move one step here, the same interval must be applied here, because we are saying it is what? A normal or equal or symmetrical what? Distribution. So that is it. So with empirical rule, one thing that we also have to put in mind is this one deals with only up to 3 standard deviation, right? So it only up to 3 standard deviation from the mean. So this is the mean, assuming you have the mean in the middle, right? So from the mean to this side is 1 standard deviation. So from the mean to this side or this side is 1 standard deviation. Then from the mean to this side and this side is what? 2 standard deviation. This is 2, this is 2, this is 1, and this is 1. So let me clean this one so that you see it clearly. All right, so your mean, which is mu, is in the middle, and this is 1 standard deviation from the mean. Do you get it? And this is also what? 2 standard deviations from the mean, right? So if you go further, it becomes what? 3 standard deviation from the mean. Do you get it? And with empirical rule, you can only go up to what? 3 standard deviation. And the format is that with 1 standard deviation, we have a percentage for that. That is what? 68%. So this one has what? 68%. And with 2 standard deviation, it also has what? 95%. And with 3 standard deviations, you have 99.7%. 99.7%. So these are the percentages you have. So from the mean, 1 standard deviation is 68%, 2 is 95, and 3 is what? 99.7%. So just put these percentages in mind, because in an examination or in any question, they can just ask you what percentage is 2 standard deviation from the mean according to the empirical rule. So if they are talking about 2 standard deviation, it means what? 75%. Do you get it? Or what 2 amount falls within 95%? And you know 95% is 2 standard deviations, right? So any amount you have here and here becomes what? The 2 amounts they are asking of. So let's look at an example under empirical rule. Let's look at an example. So a sample of the monthly amount spent for food by a senior citizen living alone approximate a symmetrical, so symmetrical what? Bell shaped, and this is the symmetrical bell shape, right? Equal distribution. Okay, and they are saying the sample mean is what? 150. The sample mean is 150. So the mean is what? $150. Okay, so that is the mean, and the standard deviation is $20. The standard deviation is what? $20. Okay. Using the empirical rule, 1. About 68% of the monthly food expenditure is between what two amounts? So they are asking us to find for the amount that falls within what? 68%. So you calculate for the amount within 68% of the expenditure. Okay, then 2. About 95% of monthly food expenditure is between what two amounts? So this one too, amounts with 95% of the expenditure. Then we can also talk about the third one, that is almost all the monthly. So this one almost. So almost is just like close to 100%, right? Okay. So we say with empirical rule, you can just go how many standard deviation from the mean? That is only 3. So we draw our bell shape and look at the two amounts that they are talking about, right? So this is our bell shape. And we say our mean is in the middle. So the mean is what? 150. Okay. Now standard deviation from the mean. Do you get it? So when you take one step, it becomes what? One standard deviation. Do you get it? So when you are coming to your left hand side, it becomes what? Negative. Do you get it? Because the distribution is now skewed towards the negative side, right? And when you move to your right hand side, it is now moving towards what? Positive side. So it means when you are going to your right hand side, you add the numbers, that is positive. So you add the numbers to what? 150, right? Then when you are moving to your left hand side, you subtract the standard deviation from the mean. Okay, so now the standard deviation is 20. So if we take one step, if we take a step like this, that is what? 20. So we are supposed to add 20 to this 150 to get 170, right? Okay, we will do same for this side because we are saying it is a normal distribution or symmetrical. So we do same for this side. So now when we subtract 20 from this 150, we get what? 130. Don't forget, under skewness, we said when you are moving towards your left hand side, the thing is what? Or the distribution is now skewing to your left hand side, and it is what? Negatively skewed. So when you are moving towards the left hand side of the mean, it becomes what? Negative. Then when you are moving towards your right hand side, it becomes what? Positive. So this is what? One standard deviation. I hope you get it. Yes, from the mean. Now we are moving on to two standard deviation from the mean. So this is the mean, this is one standard deviation, 2 will be here. So we say 2. Now what do? We add another 20 to this one to get 190. When you come here, you reduce it by 20 again to get 110. Do you see that? Okay, so now you have, this is the mean, don't forget. So now you have two standard deviation from the mean, right? We are moving on to the third one. So third one will be here, third one will be here. And so this one, what do? We add 20 to this one to get 210, right? Then this one to reduce it by 20 to get what? 90. So this one is also 3 standard deviation from the mean because 1 2 3. Do you see that? Okay, now back to the question. They are saying which two amounts has what, or that falls within 68% of the monthly expenditure. So the two amounts they are talking about, don't forget I told you 68% falls within what? One standard deviation from the mean. So if you have this in mind, you know 68% is just one standard deviation, 95% is just what? Two standard deviation, and almost is what? 3 standard deviation. So the first one is 1 standard deviation from the mean. So this is the mean. From the mean we have these two amounts, right? So this is 68%. So the two amounts, we see our solution. The first one, the two amounts is what? 130 and 170. So we see 130 and 170. These are the two amounts that falls within 68% of the monthly expenditure. Now we move on to the next one. That is 95% of the monthly expenditure falls within which two amounts? Now you know 95% according to the empirical rule is what? 2 standard deviations. So this is the mean. We are moving what? 2 steps away from the mean. So this is the first one, this is the second one, right? When you come here, this is the first one, this is the second one. So the two amounts, these are the two amounts, and this one is what? 95%. And so the 95% falls within what? 110 and 190. So 110 and 190. So these are the two amounts. These are the two amounts. Now the third one is almost. So you know almost is just like the third standard deviation away from the mean, because it is 99.7. so this is 99.7%. it's almost what? 100%. That is why they use the word almost. Do you get it? So it's still the same. Now this one is what? 3 standard deviations. So this is almost or 99.7%. And this percentage it falls within which two amounts? That is what? 90 and 210. So you have 90 and 210. So we are done with the question. This is empirical rule. So just have it in mind that with empirical rule, 1 standard deviation is just 68%, 2 standard deviations is 95%, and 3 is what? 99.7%. That is empirical rule. And with empirical rule, it deals with what? Normal distribution or symmetrical distribution. It means the mean is what? Located at the center of the distribution. When we were treating skewness, we realized the mean and the median, they will shift to the left hand side when the distribution is negatively skewed, but when it is positively skewed, they will shift towards the right hand side. But when the mean or the median or the mode is at the center, it makes the distribution what? A normal or symmetrical. Do you get it? And that one works under empirical rule. So that is it for empirical rule.